Here are 4 cards. There is a number on each card. Write down the largest 4-digit number that can be made using each card only once. So to make our number as big as possible, we want to put the biggest numbers in the column that has the most value. So we're going to have a thousands column, a hundreds column, a tens column, and a ones column. Now with this 9, I want to make that the thousands. So that's going to make my number as big as possible. And then 800, and then 74. That's going to be the biggest number I can possibly make. Write down the smallest 4-digit even number that can be made. Now to get the smallest number, I would reverse the order and I'd put 4,789, but that's not even. We know that an even number has to be a number that ends in a number that's 0, 2, 4, 6 or 8. And so what I'm going to do is swap these two round. That's the next best situation, and in that situation we get an 8 on the end rather than a 9. Okay, the question says work out 20% of £54. Now to get 10% of a number, we divide by 10. If you imagine the whole number is 100% and we want 10%, 3, 4, 5, 6, 7, 8, 9, 10. If we just want 10% of that number, we're going to divide it into 10 equal sections. So £54 divided by 10, remember all the numbers move one place to the right, so we end up with £5.40, and that's 10%. If 10% is £5.40, then 20% would be £5.40 and another £5.40, so that's £10.80. We've just done £5.40 times by 2. Rosie has £15 to spend on pens and pencils. She has to buy the same number of pens as pencils. What's the greatest number of pens that she can buy? So she has to buy the same number of pens and pencils, so we've got to buy the same of those. So 32p and 8p is 40 pence. And we're essentially saying how many times can we make that 40 pence purchase. So we're going to say how many 40p's go into £15. Now you could do that as a division. I'm going to do it as a multiplication. I think it's easier. I think you could say that if we bought 10 pens and pencils, that would be £4. And so £8 would be 20 pens and pencils. £12, that's another £4, would be 30 pens and pencils. And then we don't have enough left. We've only got £3 left, so we can't do another £4. We've only got 3 more pounds. So we're going to say how many 40p's make £3. So 40, 80, £1.20, £1.60, £2, £2.40, and £2.80. So that's another 1, 2, 3, 4, 5, 6, 7, and that takes us up to £14.80. So that's 37 pens and pencils. We can't buy another one because £14.80, if we spent another 40p, it would take us into £15.20, and that's too much. So the most we can buy is 37. Okay, next we have a stem and leaf diagram. A stem and leaf diagram, we need to use a key to help us. So it says 15 line 1 is 151 centimetres. So how do we read this? Well, it's 140, 142, 149, 151, 151, 153, 155, 157, 162, 164, 165, and so on, okay? So we need to remember the stem when we look at the leaves. Now the median would be in the middle. So the easiest way to do this would be to cross off the bottom and cross off the top, like this. We've crossed 3 off of each, off the bottom, off the top, off the bottom, off the top, bottom, top, bottom, top, bottom, top, bottom, top, bottom, top, and in the middle here we have 165. Now the other way to do that is if there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21 pieces of data, the quickest way to get to the middle is to add 1, you always add 1, and half it. And that's 11. We've got 22 divided by 2, which is 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So that's the other way of getting to the middle. Whichever way you find easier. Obviously, the more pieces of data you've got, the harder it is to cross off the top and the bottom. So the 11th piece of data is 165. The girls in the class have a median height of 162, and their heights have a range of 45. Compare the distribution. So we can see that the boys on average are taller because they have a median of 165 compared to girls of 162. And now let's look at the range. So if the girls have a range of 45, the boys, we can see their range, remember range is your biggest, take away your smallest, is 181, take away 140, which is 41. So the boys were more consistent in height. Their data was more similar because their range, a range of 41 compared to girls 45. So we're saying two things. We're comparing the average, we're saying who's taller on average, and we're stating their medians, and we're saying whose data is more consistent, closer together, because they've got a smaller range, and we've stated both the ranges as well. Okay, question 10. On the grid, translate shape A by the vector 6 minus 5. So with vectors, the top numbers left and right, and the bottom numbers up and down. So with the top number, we're going 6 to the right because it's positive. And then we're going down by 5 because it's negative. Now, I like to take a point, any point you like. I'm going to use this one here. And we're going to go 1, 2, 3, 4, 5, 6. Always count the crosses, not the squares. And then we're going to go 1, 2, 3, 4, 5 down. That means that that point is that point on that shape. So I'm then going to draw it, and it's going to look like this using a ruler. Terrible. There we go. And that's B. Okay. On the grid, translate B, this one, by the vector minus 8, 8. So we're going to go left by 8 and up by 8. So 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. And again, I've gone from that point, so that is that point. So I'm going to draw it there. And that one's C. It then says, write down the column vector for the translation that takes A to C. Well, to get from A to C, it's gone 2 left and 3 up. And left is minus, so we do minus 2, and 3 up, 3 is positive, like that. If you ever forget which way is negative and positive, just be reminded that your coordinates, see they're negative here, and positive here and positive here. So if we have positive on the top, it goes right, negative goes left, positive on the bottom goes up, negative goes down. Okay, this is a frequency tree. 60 people each took a driving test one day. 21 of those people were women, so I'm going to go ahead and put 21 here. Now immediately, before I filled anything else out, I know that if 21 women passed, then 21 people took their driving test. Let's try again. Okay, this is a frequency tree. 60 people each took a driving test one day. 21 of these people were women, so I've gone ahead and put 21 in this circle here. If 21 were women and there were 60 people altogether, then I know that 39 of them were men. This needs to add up to make this here 60. It says 18 of the 60 people failed their test. So that means that these people and these people, the two groups of people that failed, men and women, needs to make 18. So I'm going to write there that that needs to make 18. 27 of the men passed their test. So 27 of the men, that's down here, passed their test. And that tells me that if 39 men took their test and 27 of them passed, that means that 12 of them failed. Because these two have to add to make 39. If 12 of them failed, then we know that 6 women must have failed because it's got to be 18 overall. And if 6 women failed, then we've got 15 women that passed because these two need to add to make 21. One of the men is chosen at random. Now that's important. We're only picking from the men. One of the men is chosen at random, so it's going to be out of 39. Okay, one of the men is chosen at random. We're only picking from the men, so it's out of 39. What's the probability that this man failed the test? Well, we know that 12 of them failed out of the 39 men. Okay, a cafe sells cakes and scones. On Tuesday, the ratio of the number of cakes sold to the number of scones sold was 5 to 2. On Tuesday, the cafe sold 80 scones. How many cakes were sold on Tuesday? Now, ratio, I like to draw lines out. So 5 parts and 2 parts, and we're saying that cakes to scones, so 5 parts is cakes and 2 parts is scones. How many cakes? So on Tuesday the cafe sold 80 scones, so that's going to be this side. So we need this side to make 80. Now the rule with ratio is that on the lines we need to have all the same numbers. So I'm going to put 40 and 40 and 40 and 40 and 40 and 40 and 40. The reason I picked 40 is because those two had to be the same and we knew that there were 80 scones altogether. That then means, looking at this side, 40 times 5, that there were 200 cakes. And that's it. Okay, quite tricky this one. When we change from millimetres to centimetres, 10 millimetres is 1 centimetre. So normally I would say that if we're going from millimetres to centimetres, we divide by 10. But the problem with centimetres cubed is that it's a volume. So not only is it getting, if you imagine a cube for a second, not only do we need to divide by 10 for the length, we also need to divide by 10 for the height, and we also need to divide by 10 for the width. There are 3 dimensions to consider. So I'm going to take 4,500, and because it's a volume, I'm going to divide it by 10, which is 450. I'm going to divide it by 10 again, which is 45, and I'm going to divide it by 10 again, which is 4.5. If it was just a length that we were changing, we would just divide it by 10. If it was an area, we would divide by 10 and divide by 10 again. But because it's a volume, it's 3D, so all 3 dimensions need to be divided by 10, so we end up with it being 1,000 times smaller. Phone calls cost Y pound for X minutes. The graph gives the values of Y for values of X from 0 to 5. Give an interpretation of the intercept of the graph on the Y-axis. So the intercept means where it crosses, and the graph on the y-axis. So the y-axis is this one here. What does it mean that it crosses here? What does that mean? Well, if we're thinking about the fact that every time we go across one, that's another minute on the phone, and across another one is another minute on the phone, we can see that the longer we're on the phone, the more we're paying. This value here represents the fixed charge. So this represents the fixed cost, and it's the amount that you pay for not being on the phone. So amount you pay as the phone call starts. Basically, it's going to cost you that much, and then the price is going to go up from there. So that's the fixed cost. It's the amount that you pay before that phone call has begun. Give an interpretation of the gradient. Well, we can see that every time it goes across 1, so from here, if we go across 1, it's gone up from 50p up to £2. So we can see it's going up by £1.50 every time it goes across 1. And what that means, the actual gradient, means the cost per minute for being on the phone. And we can see, minute for being on the phone. Find the equation of the straight line. Now the equation of a straight line is y equals mx plus c, where m is your gradient, that's how steep it is, and c is your y-intercept. So the gradient, we know, for every time we go across 1, it goes up by 1.5. And we know that the y-intercept, c, here, was at 0.5. We can see that from the graph. So the equation of my line is y equals 1.5x add 0.5. On Monday, Tarek travelled by train from Manchester to London. Tarek's train left Manchester at 8:35. It got to London at 11:05. The train travelled at an average speed of 110 miles per hour. On Wednesday, Jill travelled by train from Manchester to London. Jill's train also left at 8:35, but it was diverted. It had to travel an extra 37 miles, and the train got to London at 11:35. What's the difference between the two trains' speed? So the first thing we're going to want to do is draw our triangle: speed, distance, time. Okay, if we want the distance, we do speed times time. If we want the time, it's distance divided by speed. If we want the speed, it's distance divided by time. So in this case, we're going to want the speed. Now, Tarek's train left Manchester at 8:35 and it got to London at 11:05. So for Tarek, let me do it this way, 8:35 to 11:05, 9:35, 10:35, 11:35, so it's going to be 2.5 hours. Okay, 1 hour is 9:35, another hour is 10:35, and then we've got another half an hour, so 2.5 hours. It travelled at an average speed of 110 miles an hour. So they've given us the speed and they've given us the time. And so we can work out the distance. The distance from Manchester to London is going to be 2.5 times by 110. Now remember, I've written 2.5 here. I know it's 2 hours 30, but 2.3 is not the same as 2.5 hours, so we need to say 2.5. Okay, 1 hour, 110, and another 110, and then 55. So that's timesing it by 2.5, timesing it by 1, timesing it by 1, timesing it by a half, and that gives us 5, 6, 7, 275 miles. So we now know that it's 275 miles from Manchester to London. Now let's look at Jill. She's going the same route, Manchester to London, but her train is an extra 37 miles. So for Jill, she's going 275, add an extra 37, which is 312 miles. So her journey is longer. She got to London at 11:35, 8:35, 9:35, 10:35, so 3 hours. So then we know to get her speed, we need to do distance divided by time, and the distance is 312 divided by the time, which is 3 hours. 3 into 3 goes once, 3 into 1 doesn't go, carry it over, and 3 into 12 goes 4 times. So Jill was going 104 miles per hour, Tarek was going 110 miles per hour, and so my final answer, which was the difference between their speeds, would be 6 miles per hour. 110 take away 104. Okay, on Monday, Ria delivered a parcel to a hospital. The travel graph represents Ria's journey to the hospital. We're told that she left home at 1 o'clock, so I've gone ahead and put that time in there. And we're also told that she drove for 30 minutes at a constant speed of 40 miles per hour. Now, if this is 30 minutes, I've gone ahead and put 1:30 here, then 2, 2:30, 3, 3:30, 4, and 4:30, and 5. She drove for 30 minutes at a constant speed of 40 miles per hour. Now, if she was going for 30 minutes at 40 miles per hour, in 30 minutes, if it's 40 miles per hour, in half an hour, she only would have got 20 miles. So I know then that this distance here is 20 miles per hour, and that enables me to mark out the rest. I've got 10 there, 30 there, and 40 there, and so on. She drove to the hospital at a constant speed. She was at the hospital for 30 minutes, so we need to come across 30 minutes there. I should definitely be using a ruler. Please use a ruler if you have one. And then she drove home at a constant speed of 32 miles per hour. Show that she does not arrive home before 4:30. Now, she is currently at the hospital at 3:30. So leaves hospital at 3:30. My word, sorry, long day. 15:30, there we go. She leaves the hospital at 3:30, and it's going to take her an hour if she needs to get home by 4:30. Now, she has 40 miles to travel. If she's going 32 miles per hour, she's not going to cover that 40 miles in enough time. So she would need to be going 40 miles per hour to travel 40 miles in an hour. She would not be able to get home doing 32 miles per hour. She's only going to be able to go 32 miles in an hour if she's travelling 32 miles an hour, and therefore she will get back after 4:30. So no good. Write 360 as the product of its prime factors. That's the tree thing going down. So all you need to do is tell me two numbers that times together to make 360, which is 36 times 10. Neither of them are prime, so we're going to carry on with both. 36 is 6 times 6, and these are 2 times 3, 2 times 3, and 10 is 2 times 5. If they're prime, we circle them, and we carry on going until we can't go anymore. These are all prime numbers. Remember, your prime numbers 2, 3, 5, 7, 11, 13, 17, and so on. They're numbers that can only be divided by themselves and 1. All we do then is the product of its prime factors, so there's a bit of a clue. We're going to take the circled numbers, 2 times 2 times 2 times 3 times 3 times 5, and we're going to change it so it's 2 cubed times 3 squared times 5. I've got the 2 3 times, that's why it's cubed, times by 3 squared times by 5.